So we are starting with integration. Now we all have studied what is derivatives, differentiation, right? So generally we use a notation of y. Y is equal to f of x. Okay. And once we derive this dy dx of y, we get dy dx of f of x. We get dy dx of f of x. So dy by dx is nothing but f dash x. Okay. So we have to remember two things. Y is f of x, but then dy by dx is f dash x. That is the first order derivative. Okay. Now from f of x, if we are supposed to go to f dash x, from f of x, if we are supposed to go to f dash x, okay. So what we are supposed to do is we are supposed to derive it with respect to x. We are supposed to derive it with respect to x. And from f dash x, if we are supposed to come back to f of x, we are supposed to integrate. We are supposed to integrate. Okay. From f dash x, we are if you want to come back to the original function from here to here, we'll have to integrate. I hope this thing is clear. So those who intend to copy something, just copy this part. This part. Okay. I'll wait for a few seconds over here. Okay, good. So basically, when we start with integration, first and foremost, we are supposed to learn all the formulae. Okay, and many things with respect to trigonometry and then algebra is going to get utilized over here. So our integration basic formulae should be, very much into place. So integration formula, you can simultaneously write. First one is integration of x raised to n dx. Now this is the integration sign. It seems like s or f you can call, but then it is neither of those two. It is integration sign, and we write dx. Dx is nothing but integrating with respect to x. So the formula over here is x raised to n plus 1 upon n plus 1 plus c. Okay. Now plus c is a compulsory thing which we have to write in all integration formula. Okay. Plus c. Why this plus c occurs? Definitely, I'll be telling you after a while. Second formula: integration of e raised to x dx, an exponential function, is e raised to x plus c. Third one is a raised to x dx, a raised to x upon log a plus c. Okay. Now e is nothing but Euler's identity. It's a fixed constant. It has a fixed value, like pi in mathematics. So these are the first three formulae, I should say. We have a long list of formulae in integration. We have just written only three formulae. Okay. X1, integration of 1 upon x dx is equal to log modulus x plus c. Don't compare this formula with derivatives formula. Learn the derivatives or differentiation formula separately and the integration formula separately. Okay, so 1 upon x is log modulus x, I should say. Then integration of a constant. And that constant, let it be 1, be x plus c. Now, if at all you recollect, derivative of a constant is always of a single constant is always 0. But then in integration, try to understand that the integration of a single constant is not 0 at all. Okay, and while I'm solving the problems, you'll get a clear-cut understanding about it. Okay, sixth one. Now all the trigonometric formulae, sin x dx, then we are having cos x dx, Then we are having sec x dx, cosec x dx. Okay, so integration of sin x is minus cos x. Just remember that. Okay, derivatives it was something else. Here it is minus cos x. Cos x is sin x plus c. Don't worry about the plus c part. It will be clarified to you on. Sec x is sec x tan x plus c. Sec x tan x plus c. Okay, and cosec x is minus cosec x cot x plus c. Okay, 6, 7, 8, 9 trigonometric formula. And there is no formula for log x and root x. Okay, derivatives we had this formula for log x and root x. Integration there is no formula for log x and right. Before I forget, I thought I should tell you. Then next one, integration of tan x dx, integration of cot x dx. Just a second, I just made a mistake over here. 1 second, I'm sorry. This should be log mod sec x plus tan x. I'm sorry, log mod sec x plus tan x plus c, and this has to be log mod cosec x minus cot x plus c. Fine. So apologies for that. Log mod sec x plus tan x plus c and log mod cosec x minus cot x plus c. Fine. I was thinking about derivatives, so really sorry for that. Integration we have a separate formula. I hope you have made the correction. Okay, so this will be log mod sec x plus c, and this will be log mod sin x plus c. Log modulus sin x plus c. Now the 12th and 13th one, integration of sec square x dx is equal to tan x plus c. Integration of cosec square x dx minus cot x plus c. Integration of sec square x is tan x plus c, and integration of cosec square x dx is minus cot x plus c. Okay. Fourth one, 14th one, sorry. Integration of sec x tan x is sec x tan x dx. I should write dx over here. Sec x plus c. Integration of cosec x cot x dx is equal to minus cosec x plus c. Minus cosec x plus c. Okay. And two formulae also you remember, more two formulae. Integration of 1 upon 1 plus x squared dx is tan inverse x plus c, and the 17th one, integration of root 1 minus x square is sin inverse x plus c. Because this two will be quite often required while we solve the problems. Okay, so let's take some basic integration problems and solve it. Okay, and while we solve the integration problems, we need to take care of something which is called as the chain rule. Okay, chain rule behaves a bit different over here in integration. So we need to be very clear about it. Okay, so let me take some problems. Integration of sine 2x dx. Integration of sine 2x dx. Fine. So as we know, the integration of sine x is minus cos x. So integration of sine 2x will be minus cos 2x. Okay. And if we compare, x is getting replaced with 2x. X is getting replaced with 2x. Now we need to put a checkpoint over here. Derivatives, we did not do anything of that manner. But then in integration, we need to put a checkpoint on what is x getting replaced with. What is x getting replaced with? Can you tell me? What is x getting replaced with? X is getting replaced with 2x. Now focus on this 2x. Is 2x a linear algebraic term? Okay. Is 2x a linear algebraic term? Yes, because obviously this is an algebraic term because x is in the base and the power of x is 1. Hence it becomes an algebraic term, but then with the power 1. So it is a linear algebraic term. Is this clear for you? Then only we can proceed. If it is a linear algebraic term, then only we can proceed. So sin x, the integration is sin 2x. So sin x integration is minus cos x. So sin 2x integration will be minus cos 2x. Okay, upon dy dx of 2x. Now why this upon dy dx of 2x? In derivatives we did the same thing. In the numerator. This part was up over here, besides in the numerator. But then in integration, the same thing will be placed in the denominator. Okay, the same thing will be placed in the denominator. And obviously 2x is a linear algebraic term. So that's the checkpoint in integration. So this is minus cos 2x upon 2 plus c. Minus cos 2x upon 2 plus c. Fine. Is the first problem clear? Those who are referring OP Malhotra book, this is from exercise 313A. These problems which I'm taking right now is from exercise 13A. Okay, so later on you can just mark the problems which we are doing for your reference. Next problem. Integration of two sine 3x dx. So 2 being a constant, I will take it outside. Only a constant can come outside the integration sign. You cannot take the variable term outside. The variable is x. So this will be sin x integration is minus cos x. So sin 3x integration will be minus cos 3x. Okay, what is x getting replaced with? X is getting replaced with 3x. X got replaced with 3x. So is 3x a linear algebraic term? Yes, it's an algebraic term because x is in the base and power of x is 1. So it is a linear algebraic term. So minus cos 3x. Okay, since there is a minus sign, hence I'm putting this bracket. Why we need to place this bracket? Because there is a minus sign upon d by dx of 3x. Upon d by dx of 3x is because in integration we have to put this chain rule part, the derivative part down. Okay, so eventually this answer will be minus cos 3x upon 3 plus c. Okay, Fine. Then let's take some other example. Integration of cos 5x upon 2 dx. So half being a constant will go outside, cos 5x dx. I'll compare this with which formula? I'll compare this with cos x formula. So as we all know, I've given you the formula list. Cos x is, oh sorry, it should be sin x in integration. So cos 5x will be sin 5. Now if you compare both the terms, what is x getting replaced with? X is getting replaced with 5x. X is getting replaced with 5x, and 5x is a linear algebraic term. 5x is a linear algebraic term. Since it is a linear algebraic term, so yes, we can apply the chain rule. So this is sin 5x upon d by dx of 5x plus c. Okay, so sin 5x upon derivative of 5x. Now this is the derivative part. 5 into this 2 will be 10 plus c. Okay, so this will be 10 plus c. Okay, now just a brief understanding about what the c is. Okay, once you finish writing this, we'll just try to understand what is this c all about. Fine. Okay, so let us just proceed. What is the derivative of 2x plus 1? The derivative of 2x plus 1 is, if this is f of x, f dash x. F dash x is the derivative part. Derivative of 2x plus 1 is 2. What is derivative of 2x plus 2? It is again 2. 2x plus 3, the derivative is 2. Okay. So from here to here, the derivative I've taken, it's same 2. But then from 2, I want to get back over here. I will have to integrate. So in that case, if I integrate all these terms, if I integrate f dash x, I am supposed to get f of x. So what is the right answer? Is it the first one, second one, or the third one? Okay. Are you trying to think over it? All three are correct. Basically, all three are correct. The only thing which is changing is this constant. So it can be 1, 2, 3, or any other known or unknown constant. So this is termed as plus c when we integrate. Is the understanding clear? I hope you understood how that plus c works, and what is the idea behind that plus c. Okay. Yeah. So next problem, integration of cos x square 2x dx. So integration of cosec x is cosec square x. I'm sorry. The integration of cosec square x is minus cot x. So integration of cosec square 2x. Okay. Integration of cosec square 2x will be minus cot 2x. X is getting replaced with 2x. Now 2x is a linear algebraic term. Okay. So yes, we can proceed with the chain rule. Otherwise, there was no other option for us. So minus cot 2x d by dx of 2x, which will be in the denominator. Why this is in the denominator? Because we are integrating. Had it been derivatives, we could have just placed this in the numerator. plus c, and this will be 2. Okay, so that will be your final answer, minus cot 2x upon 2 plus c, minus cot 2x plus 2 upon 2 plus c. Okay, yep. So let us proceed with the next problem. Integration of minus cosec 3x cot 3x dx. Now, first of all, you need to be very much sure about the formula. If you don't know the formula, then it will be a tough task for you. So take the minus sign outside. Cosec 3x cot 3x dx. Cosec 3x cot 3x dx. Okay. So we have this integration of cosec x cot x. The integration of cosec x cot x is, if I'm not wrong, see, I've written it somewhere. Cosec x cot x minus cosec x plus c. Okay, so we'll write minus cosec x. So what will be the integration of cosec 3x cot 3x? It will be minus cosec 3x. It will be minus cosec 3x. So if you compare this, what is x getting replaced with? X is getting replaced with 3x. My question to you is 3x linear algebraic term? This thing we never checked in differentiation, but then here it is quite essential. Is 3x linear algebraic term? The answer is yes, it's a linear algebraic term. So we can go ahead and solve this, right? So if we solve it further, okay, so it will be cosec 3x cot 3x. Integration will be minus cosec 3x, and this minus sign will also be there. So it will be minus into minus cosec 3x upon d by dx of dx plus c. So cosec 3x upon 3. Okay, this d by dx of 3x, it came because of the chain rule. It came because of the chain rule. So if you wish to copy this, you can just copy and let me know once done. Okay, so we'll move on with the next set of problems from the first chapter of integration as per ISC and OP Malhotra, that is Eschan textbook. Just a second. Let me just erase a few slides. Yeah. So yeah, so let us just focus on few other problems. Integration of 1 upon 1 plus cos x dx. Okay, now try to understand whenever there is 1 plus cos or 1 minus cos in the denominator. Okay, make it a rule for yourself. If it is 1 plus cos or 1 minus cos in the denominator, we'll just apply half angle formula or double angle formula, as you say. So we know this half angle formula of 1 plus cos 2x. It is 2 cos square x. It is 2 cos square x. Okay, we know this, right? Half angle formulae are really very important for the entire syllabus. So what is 1 minus cos x? If 1 plus cos 2x is 2 cos square x, so what is 1 plus cos x? So what is the half of x? It is x by 2. So 2 cos square x by 2. So this will be 1 upon 2 cos square x by 2. 1 upon 2 will go outside. Okay. 1 upon cos square x by 2. So this is half integration of 1 upon cos. What is 1 upon cos? 1 upon cos is nothing but the reciprocal of cos. And what is the reciprocal of cos? Sec. Okay. Reciprocal of cos is sec. But don't you think this 2 will also go up? 1 upon cos square will be sec square. Okay. By the reciprocal logic. Fine. Now integration of sec square is tan. Integration of sec square x is tan x. I'll just show you the formula. 1 second. Yeah. Integration of sec square is tan. So integration of sec square x by 2 will be tan x by 2. Okay. So integration of sec square x by 2 is tan x by 2. I'll have to compare this with integration of sec square x. X is getting replaced with x by 2. Is x by 2 linear algebraic term? Yes, because x is in the base and the power of x is 1. So it's a linear algebraic term. Chain rule can be very well applied. So I'll take you to the next slide, and this will be half tan x by 2 d by dx of x by 2 d by dx of x by 2 plus c half tan x by 2 upon half, which is equal to tan x by 2 plus c. Okay, that should be your final answer. Is it okay? Yes. Next question. 1 upon 1 minus cos 2x. If there is 1 minus cos in the denominator, our rule says that we have to apply half angle. 2 sine square x. Okay, half outside, 1 upon sine square x. Half outside, 1 upon sine square will be cos x square x. Half outside, integration of cos x square x is minus cot x. Okay, integration of cos x square x is minus cot x plus c. So this is equal to minus cot x upon 2 plus c. Is that fine? Okay. I repeat, these are the problems from the 13A exercise of OP Malhotra. Yep. Okay. Integration of 1 minus cos 2x, 1 plus cos 2x. Apply half angle formula in the numerator as well as denominator. So this is 2 sine square x in the numerator and 2 cos square x in the denominator. Half angle formula is a very, very important thing. So this is tan square x dx. You need to put a bracket. It's okay if you don't put a bracket over here. It's a single term because 2 gets cancelled. Okay, and sine upon cos becomes tan, along with the square it becomes tan square. Okay, now see, basically we have the formula for sec square, we have the formula for sec square and cosec square, but then we don't really have the formula for tan square and cot square. I hope you are listening very carefully. You have the formula for tan sec square and cosec square, but then for tan square and cot square we don't have any formula. So whenever in integration, wherever throughout the entire syllabus, be it any chapter of integration or differential equations, whenever tan square x appears, you have to apply first fundamental identity for tan square as well as cot square x. Is the point clear which I'm trying to make over here? Whenever you see tan square or cot square, you have to use fundamental identity first. So this will be sec square x minus 1 as per the fundamental identity. Okay. And then individual integration, and then individual integration. Individual integration. So this will be integration of sec square x dx, integration of 1 dx. So this is tan x minus x plus c. Integration of sec square x is tan x, integration of 1 is x, and this is plus c. Okay. I hope you're understanding the things which are being taken till now. Okay, let us just proceed. Integration of root of 1 plus cos x. Just make use of the half angle formula. Very handy thing. Okay, so the root will be split into two parts. We can split the root into two parts because there is a multiplication sign over here. It's not visible, but then it has to be multiplication. So root can get split into two parts. So this is equal to root 2 goes outside, and this will be integration of cos x by 2 dx. Integration of cos x by 2 dx. Now further part I am not solving because I'm very sure by this time you people will be able to do it. Cos x is sin x, so cos x by 2 is sin x by 2. Okay, cos x integration is sin x, cos x by 2 integration will be sin x by 2. Okay, what is x getting replaced with? X is getting replaced with x by 2. Is x by 2 linear algebraic term? Yes, it has to be. It is a linear algebraic term because x is in the base and the power of x is 1, and the power of x is 1. Fine. So I hope you have understood this and you can take it forward from here. We'll dedicate our time on the next problem. Okay. Let me just write down the next question. Cos x root 1 plus cos 2x. Okay. 1 second. We'll just come to this problem a bit later. Okay. So cos x minus sin x upon cos x plus sin x. 2 plus 2 sin 2x. Okay. So let us just solve this. And obviously we'll have to write dx. So cos x minus sin x, cos x plus sin x into 2, and this will be 1 plus sin 2x dx. Now let me tell you one thing. 1 plus sin 2x is cos x plus sin x the whole square, and 1 minus sin 2x is cos x minus sin x the whole square. So remember this, these are half angle formula or double angle, whatever you say. Had it been x over here, we'll just write x by 2 on the right hand side. 2x becomes x, so x will become x by 2 on the right hand side. Okay. So in this case, we are having 1 plus sin 2x. We'll apply the half angle formula which I've just given to you. cos x plus sin x the whole square dx. Okay, now if you just observe this entire term and this one term will get cancelled, so the square gets cancelled over here. Okay, 2 being a constant, 2 will move outside, 2 will move outside, right? 2 being a constant, 2 will be moving outside. Cos x minus sin x into cos x plus sin x dx. Cos x minus sin x into cos x plus sin x dx. Okay, if you just observe, we are having cos x minus sin x, and there is one more term left over here, cos x plus sin x. Okay, there were two terms, one term got cancelled. Okay, now we'll apply this. So a minus b into a plus b. So cos square x minus sin square x dx. Cos square x minus sin square x, right? A square, a is cos x, cos x the whole square is cos square x, cos x the whole square is cos square x. Okay, and b is sin square x, b is sin x, so b square is sin x the whole square, which is sin square. Now try to understand, there is one more half angle formula, cos square x minus sin square x, which is cos 2x. Okay, I'll give you a list of half angle formula of cos 2x. Cos 2x is equal to 2 cos square x minus 1. It can also be equal to 1 minus 2 sin square x. It can be equal to cos square x minus sin square x. 1 minus tan square x upon 1 plus tan square x. So there are 4 half angle formulae for cos 2x. Okay, it's not 1, it's not 2, but then 4. And you have to remember this. You have to remember this. Right? Okay. So cos square x minus sin square x is nothing but cos 2x. So this is 2 sine 2x upon d by dx of 2x as per the chain rule, because you are comparing this with cos x formula. So x is getting replaced with 2x, and 2x being a linear algebraic term, we can apply the chain rule. Okay, d by dx of 2x will go down, and then further you can simplify. Is it okay? Okay, perfect. Next set of question. Integration sin x plus cos x upon root of 1 plus sin 2x. Root of 1 plus sin 2x. Sin x plus cos x upon root of 1 plus sin 2x. I just gave you a formula for this. 1 plus sin 2x, the half angle formula. Because the angle on the left hand side becomes exactly half on the right hand side. Okay, so this is cos x plus sin x the whole square. Okay, the square and the root in the denominator will get cancelled. Square and the root in the denominator will get cancelled. So we are left with sin x plus cos x upon cos x plus sin x, and then Both are the like terms and we get 1 over here. And integration of 1 will be nothing but x plus c. Okay. Whenever the integration sign goes, along with that dx also goes, and plus c comes into picture. Was this problem simple? Okay. Let us proceed with few more problems. Okay. Tan inverse of sine 2x upon 1 plus cos 2x. Sine 2x plus 1 plus cos 2x. Okay. So this is tan inverse of sine 2x half angle formula. Okay. 1 second. Sine 2x half angle formula. So we'll just write 2 sin x cos x and 1 plus cos 2x formula is 2 cos square x. 2 cos square x. So tan inverse of, I hope you know the half angle formula for sine 2x and 1 plus cos 2x. 1 plus cos 2x is 2 cos square x and 1 minus cos 2x is 2 sin square x. So as you can see, the 2 and 2 will get cancelled. Cos x, one term and down, the square part will get cancelled. Tan inverse of tan x. Tan inverse of tan x is x. Okay. So I just forgot to write the integration sign everywhere. So just place it accordingly. Tan inverse and tan got cancelled. So we are left with x. Now what is the integration of x? Which formula should we apply for integration of x? For integration of x, we'll apply the formula for of x raised to n. For integration of x, we'll have to apply the formula of x raised to n. So that is x raised to 1 dx. So x raised to 1 plus 1 upon 1 plus 1. X raised to n plus 1 upon n plus 1. X raised to 2 upon 2 plus c. I hope this is very much clear for everyone. Okay, let's take a few more problems. Okay, integration of cos inverse of 1 minus tan square x upon 1 plus tan square x. 1 minus tan square x upon 1 plus tan square x. So as you can see, the half angle formula for cos 2x in terms of tan. So 1 minus tan square upon 1 plus tan square will be cos 2x. Okay. So this will be 2x because cos inverse and cos gets cancelled. 2 goes outside and we are going to apply x raised to n where n is 1. Where n is 1. Okay. Yes. So let us just proceed with the next problem. Now we also have seen this in trigonometric functions and at many other places. when I have sin x, this can be expressed in terms of cos. So sin x is equal to cos pi by 2 minus x, and cos x is equal to sin pi by 2 minus x. Sin x is equal to cos pi by 2 minus x, and cos x is equal to sin pi by 2 minus x. So this formula will become very handy. This formula will become very handy, when we solve certain problems. So let's take the next problem. Cos inverse of sin x. Cos inverse of sin x. Okay. So I'll just replace the sin with cos so that cos inverse and cos will get cancelled. Okay. So the sin I have replaced with cos. So cos inverse and cos is getting cancelled, and we are left with integration of pi by 2 minus x plus c. So individual integration of pi by 2 minus integration of x dx. We can write this x as x raised to 1. We can write this x as x raised to 1. Okay. Now integration of a constant is not 0. That constant has to go outside, and we'll write pi by 2 integration of 1 dx minus x square by 2. Why x square by 2? Because I'll apply here the formula of x raised to n. I'll apply the formula of x raised to n. So it is x square by 2. Okay, x raised to n, 1 plus 1 upon 1 plus 1. Now see, there is one integration sign still left. So don't write plus c. When all the integration signs get cancelled, or sorry, when we apply the formula, so whenever the integration sign goes away, you can write plus c. Plus c is not a very big thing, so it's just a formality. Now integration of 1 is x. Integration of 1 is x. So plus c is for the entire problem. Don't write plus c over here and plus c over here. Plus c is for the entire problem. Okay, so that's your final answer. I hope you guys are able to understand. Okay, next one. Integration of 1 upon 1 minus sin x. Now, if we have 1 plus sin x or 1 minus sin x in the denominator, I would insist that you people should take the conjugates and multiply and divide. Conjugate of the denominator, that is rationalization. Okay. So, and this is only for 1 plus sign or 1 minus sign in the denominator. Okay. In the denominator. 1 plus cos, 1 minus cos in the denominator, we take conjugates. We take half angle. 1 plus cos or 1 minus cos in the denominator. We take half angle form. But 1 plus sign, 1 minus sign will take conjugates. Multiply and divide with the conjugates. So this is 1 plus sin x, 1 square minus sin x the whole square, because this is a minus b into a plus b. Okay. So 1 plus sin x upon 1 minus sin square x dx. 1 plus sin x upon 1 minus sin square x dx. Okay. Now what is 1 minus sine square x? 1 minus sine square x is cos square x. So 1 plus sine x upon cos square x dx. Split this into two parts. 1 plus cos square x sine x upon cos square x dx. 1 plus cos square x. Cos reciprocal is sec. So this will become sec square x plus. Now we have to write this in a specific format. Cos I have split it into two parts, cos x and cos x. So the first part will become tan x, and the second part 1 upon cos x will become sec x. The blue colored part will become tan x, and the red colored part will become sec x. Okay, so this has to be integration of sec square x plus tan x into sec x dx. So integration of sec square x dx plus integration of this, I'm just reversing it because mathematically that is very much correct. Okay, so integration of sec square x will become tan x. We know the formula for trigonometric integration, and the integration of sec x tan x is sec x plus c. Okay, so that's how we are going to proceed with this. I hope everybody has copied this. So remember the ground rule over here. If we are having 1 plus sine x or 1 minus sine x in the denominator, we are going to take conjugates and multiply and divide with the conjugates. Yep. So the next problem, let's take 1 plus sine in some other manner. Root of 1 plus sine 2x. Now this is a root and this is not a denominator. So no need of taking conjugates and all. Okay, just apply the half angle formula. 1 plus sine 2x is cos x plus sine x the whole square dx. Cos x plus sine x the whole square dx. The square and root gets cancelled. Square and root gets cancelled. So we are left with cos x plus sine x dx. Okay. Then individual integration. Cos x becomes sin x, and sin x becomes minus cos x. Okay, and that is your final answer. Just what you can do is you can just write this as minus later on. Plus into minus will be minus later on. Okay, next problem. Integration of root of 1 plus sine x by 2 dx. Now 1 plus sine 2x is equal to cos x plus sine x the whole square as per the half angle formula. So 1 plus sine x by 2. What is the half of 2x? Half of 2x is x, right? So what is the half of x by 2? X by 2 divided by 2. X by 2 into 1 by 2. So it is x by 4. So the half of x by 2 is x by 4. So this will be cos x by 4 plus sine x by 4 the whole square. Cos x by 4 plus sine x by 4 the whole square. So as you can see the root over here, we are going to replace 1 plus sine x by 2 with cos x by 4 plus sine x by 4 the whole square. So that is how the half angle formula works. So I'll write the next step on the next page, or rather I'll just put it over here. Root of cos x by 2 plus sine x by 4 the whole square. Cos x by 4 plus sine x by 4 the whole square. Yeah. Now the root and square will get cancelled. Okay. So this will be integration of cos x by 4 plus sine x by 4. Cos x integration is sine x. So cos x by 4 integration will be sine x by 4 upon d by dx of x by 4. See, I'll compare this with cos x formula. So the green colored part is my x. So x is getting replaced with x by 4 in both the cases. And x by 4, is it a linear algebraic term? Yes or no? X by 4, yes, it is a linear algebraic term where x is in the base and the power of x is 1. Plus cos x by 4 d by dx of x by 4 plus c by 4 plus c. Okay. Sine will be minus cos. I'm sorry for that. Sine will be minus cos. Right. Then d by dx of x by 4 is 1 by 4. Then that 4, 1 by 4, you can take a common denominator and then you can simplify further. This much is good. Next problem. Integration of cos square x minus sine square x upon the root of 1 plus cos 4x. Half angle formula both in the numerator as well as denominator. Cos square x minus sine square x is cos 2x, and down half angle for 1 plus cos 4x. So it will be 2 cos square 2 cos square 2x. See, for 1 plus cos 2x, the half angle is 2 cos square x. So 1 plus cos 4x, if this becomes 4x, this has to become 2x. Okay. Now split the root in the new denominator because there is a multiplication sign between 2 and cos square. So we have splitted this. Okay. Take 1 by root 2 outside. Take 1 by root 2 outside. So this will be cos 2x upon cos 2x. The square and the root gets eliminated. This root and the square got eliminated. So this will be 1 by root 2 into integration of 1 dx, and integration of 1, you all know that is x plus c. Okay. Yeah. Next problem. Integration. Now this is a relatively a simple one. 3 cos x square x plus 2 sin 3x dx. Individual integration. Try to understand the format of writing. 3 will go outside, cos x square x dx. 2 will go outside, sin x and 3x dx. Integration of cos x square x is minus cot x, and integration of sin is minus cos 3x upon d by dx of dx upon d by dx of 3x, that is 3. Okay. Moreover, this will get cancelled, and then you can just simplify this further by taking the minus sign, by considering the minus sign. Okay. I hope you all know how this 3 came. This 3 came because of d by dx of 3x. Chain rule. And 3x is a linear algebraic term. Yeah. Next problem. Integration of 1 upon sin square x cos square x dx. So the 1 in the numerator, I'll replace it with sin square x plus cos square x upon sin square x cos square x. Okay. The 1 in the numerator got replaced with sin square x plus cos square x. Fundamental identity. Now split sin square x upon sin square x cos square x plus cos square x upon sin square x cos square x dx. Sin square is gone and cos square is gone. So we are left with 1 upon cos square plus 1 upon sin square. One upon cos square plus 1 upon sin square. Right? So this 1 upon cos square. So cos square goes up and this sin square also has to go up in the numerator. As in, we'll take the reciprocals. Cos square and sin square reciprocals. Cos square, if it is going in the numerator, it will become 6 square x plus cos x square x, because sin it goes in the numerator, it becomes cos x square. So this is integration of sec square x dx plus integration of cos x square x dx. Individual integration. So this becomes tan x and this becomes minus cot x as per the integration formula. Okay. Hello. So then we'll continue with the next set of problems. Yeah. So integration of cos 2x plus 2 sin square x upon cos square x. Okay. Now cos 2x, I have given you the half angle formula. It is 1 minus 2 sine square x. Cos 2x is nothing but 1 minus 2 sine square x, right? Okay. As per the half angle formula. And this 2 sine square x, I'll just keep it as it is upon cos square x dx. So don't you feel this 2 sine square x and 2 sine square x will get cancelled? So this will be 1 upon cos square x, and 1 upon cos square x is sec square x, and integration of sec square x is tan x plus c. Have you understood this one? Please copy. If you're done with this, let me know. Hello. So are we done with this? Okay, fine. Next one. Integration of sin x cos x dx. Okay, so I'll multiply and divide with 2. Okay. We need to understand one thing over here. There is nothing called as product rule or quotient rule in this chapter of integration. Okay. So what is 2 sin x cos x? As per the half angle formula, it is sin 2x, right? So this is sin 2x upon 2. Half will go outside. Integration of sin 2x dx. Okay. The purpose of placing this 2 over here was so that I could apply the half angle formula in the numerator. And remember, no product rule or quotient rule is there in this chapter of integration. So half sin 2x integration is minus cos 2x upon d by dx of 2x. Chain rule. And chain rule is applicable because when I compare this with sin x, okay, x is getting replaced with sin 2x. X is getting replaced with 2x, and 2x is linear algebraic term. Okay. So minus cos 2x, 2 into 2, eventually that will be 4. Eventually that will be 4. Okay. Next one. Next problem. Integration of sin x into sec square x dx. Sin x upon cos square x dx. Sin x upon cos x. 1 upon cos x dx. So this is tan x into sec x dx. This becomes tan x and this is sec x. So this is sec x tan x. I'm just reversing the order. And what is the integration of sec x tan x? Can you tell me, guys? Sec x tan x. That's sec x plus c. Final answer. Okay. Have you copied this? Next one. Convert everything into sine and cos. That is the basic rule of trigonometry. Okay. So 1 plus cos x upon 1 plus sin x upon cos x dx. Okay. This cos and this cos is getting cancelled, and we are left with 1 upon 1 plus sin x dx. Now what about this? How to solve this? We have already solved such kind of a problem, wherein if there is 1 plus sign or 1 minus sign in the denominator, multiply and divide with the conjugates. Okay, so this I'm not going to solve further, right? Yeah. Next, integration of sine square x dx. Now whenever we have integration of sine square x or cos square x, we are going to use the half angle formula of 1 plus cos 2x or 1 minus cos 2x. So 1 minus cos 2x is equal to 2 sine square x. Okay, therefore what is sine square x? Is it equal to 1 minus cos 2x upon 2? Is sine square x is 1 minus cos 2x upon 2? Yes, that is by cross multiplication. So this will be 1 minus cos 2x upon 2. Take the 2 outside. Integration of 1 minus cos 2x. Individual integration. Integration of this 1 is x, and integration of cos 2x is sine 2x upon 2. Why upon 2? Because we'll derive it with 2x down in the denominator. This being an integration chapter. Plus c. Then you can multiply this half within the bracket. Then you can multiply this half within the bracket. Okay. So just remember, whenever we are having sine square x or cos square x problem, we can just use half angle formula for 1 plus cos 2x or 1 minus cos 2x. You can try this problem at home. Integration of cos square x. You can try it at home. Only this thing will be plus, and this will be cos square x. Okay. You should know the half angle formula. Cos square x, I leave it up to you. Now integration of sine square mx dx. So 1 minus cos 2 mx is equal to 2 sine square mx. Okay, I'll write it once again. 1 minus cos 2 mx is equal to sine 2 sine square mx. So what is sine square mx? 1 minus cos 2 mx by 2. So I'll just replace sine square mx by 1 minus cos 2 mx by 2. Take half outside. Integration of 1 minus cos 2 mx dx. Half integration of 1 is x minus cos 2 mx is sine 2 mx upon dy dx of 2 mx, which is 2m, plus c. Plus c. I don't have space over here to write. You just write plus c. Okay. And why we are writing this 2m? Because of the chain rule. I compared this with cos x. X is getting replaced with 2mx. X is getting replaced with 2mx. Okay. 2mx is a linear algebraic term because x is in the base and the power of x is 1. Fine. So net net, what should we remember is whenever we are having sine square or cos square, use half angle of 1 plus cos and 1 minus cos. Yeah. Now let's take cube sine cube x dx. Okay. Now see triple angle formula. Sine 3x is equal to 3 sine x minus 4 sine cube x. Okay. Therefore 4 sine cube x is equal to 3 sine x minus sine 3x. I have to extract the value of sine cube x. We require this sine cube x. Okay. So sine cube x is what? 3 sine x minus sine 3x upon 4. 3 sine x minus sine 3x upon 4. Okay. So in place of this sine cube x, I am going to substitute this 3 sine x minus sine 3x upon 4. So sine cube x, cos cube x integration will use triple angle formula. So integration of 3 sine x minus 3 sine x minus sine 3x upon 4 dx. 1 upon 4 goes outside. Integration of 3 sine x dx minus integration of sine 3x dx. Okay. 3 being a constant, it will remain as it is outside the integration sign. Sine x integration is cos x, or rather minus cos x minus cos 3x. If sine x integration is minus cos 3x, cos x, sine 3x integration will be minus cos 3x upon, can you tell me? Can you tell me? Upon? Yes, waiting for your answer. Correct. Upon d by dx of 3x, which is 3. Chain rule part, because 3x is a linear algebraic term. Are you understanding? Okay. So the last problem, integration of
cos cube x dx. See, cos 3x is equal to 4 cos cube x minus 3 cos x. Triple angle formula. So what is 4 cos cube x? Cos 3x minus plus 3 cos x. This will go on the other side, it will become plus. So cos cube x is equal to cos 3x plus 3 cos x upon 4. This I'm going to put it over here. Just remember, sin cube x, cos cube x, the formula becomes triple angle formula. Formula to be applied is triple angle formula. Okay. Yeah. Next step, just replace cos cube x with whatever we have just calculated. Cos cube x is cos 3x plus 3 cos x upon 4 dx. So 1 by 4 will go outside. Integration of cos 3x dx. Integration of 3 cos x dx. So 1 by 4 cos 3x, chain rule, sin 3x upon 3 plus 3 outside, cos x integration is just sin x. Okay, and this 3 is due to the chain rule, d by dx of 3x, which comes down. Okay, so that is the end of lecture number 1 of integration, indefinite integration, SYISC. The problems are taken from OP Malhotra textbook, and I hope the lecture was quite clear for all of you. Okay, yeah, thank you.